Okay, so I have a biphenyl molecule with substituents in the auto positions. Now, those substituents tend to lock up the biphenyl so that it blocks the free rotation of the two phenyl rings. So they tend to lock up a conformation that gives them ATROPISOMERs. So imagine we have biphenyl with these groups in the auto positions, and we are looking at the molecule from the side. Because this B is pointing out towards, this B prime is pointing out towards me, and the A prime is pointing away from me in the horizontal direction, and then the A and B are in the vertical plane. So anytime you see a shaded line here, it means that side is pointing towards you, and then the other side is pointing away. But if the lines are just the same, it means they are in the plane of the board. So looking at here, I will see A prime and B prime first. B prime will be pointing to my right, A prime to my left, and then I will see A and B from behind. Okay. Now to assign the RNS configuration for this, since I started looking at the molecule from the side of A prime and B prime, I have to start from A prime and B prime first. So I have to choose which of the two is lower in priority. So if B is lower in priority than A, I have to start with B. If A is lower in priority than B prime, I have to start with A prime. So I'm going to assume that in this case B prime is lower than A prime, and then from there I have to look at A and B, which one is high in priority. If A is high in priority than B, then I have to go towards A. If B is higher in priority than A, then I have to go towards B. So this will give me S, this will give me an R. So let's try with a specific example. Okay, this is a propyl group. Okay, now I have this biphenyl which is locked up by these auto groups so that there is no free rotation along this axis. Now let's try and assign our RNS configuration for this. So I'm going to call this group, this side A and this B, A prime and B prime. Let's see. If I'm looking at the molecule from the side, okay, let me change it and look at it from this side. If I'm looking at the molecule from this side, I will see A and B first, and A and B are in horizontal direction, where the bromine, which is B, is pointing towards me, and the carboxylic acid is pointing away from me. I'll see the carboxylic acid on my right, and the bromine will be on my left. And then I will see A prime and B prime from behind, up and down. Propyl group right here, and this is A prime, B prime. Okay, now since I started from this side looking at A and B, I have to start assigning. Started from A and B. Now A and B, which one is higher and which one is lower in priority? Of course, the bromine is higher than this carboxylic acid because of the carbon. So I have to start with this side first. So I have to start from here, and then I have to look at A prime and B prime, which one is higher in priority. So, of course, the propyl group is higher in priority than the hydrogen. In that case, I have to go from here to here. So that is a counterclockwise direction, and therefore that's a nice configuration. Here. Now, if I was standing at the other end, let's see what we are going to get. It has to be the same. So if I was standing here, then I will see A prime and B prime first, and they are in vertical arrangement. And then the A and B will be behind. I'll see B to my right. And then A will be to my left. Okay, so since I started looking at the molecule from this side, I have to assign starting from the vertical position. Then I have to look at A and B, which one is lower in priority, of course. So A prime and B prime, which one is lower in priority, of course, is hydrogen. So I have to start from B prime. And then I have to look at A and B, which one is high in priority. Of course, the bromine is high in priority than the carboxylic acid. So I have to go from here to here, and therefore this is S direction. So either way will give me the same configuration. Okay, so let's try using a different compound. So you have this biphenyl group. Okay, so I have this biphenyl compound. There's bromine, carboxylic acid, and hydrogen. And we are trying to determine the RNS configuration for this compound. So let's call this A, let's call this B, let's call this A prime, let's call this B prime. And then let's stand here and look at the molecule. So I will see the vertical group first. Then I will see the horizontal groups behind it. Bromine will be pointing to my right. Then carboxylic acid pointing to my left. Okay. So since I started from here, I have to start assigning from the vertical position. So A prime and B prime. Also B prime is lower in parity than A prime in this case. So I'm going to start with hydrogen. And then looking at this and this, the bromine is high in parity than the carboxylic acid. So I have to go from here towards the side. And that is counterclockwise. So that's a nice. And then can go this direction. So either way, if you stand here, you will still get an S. So I'm going to assume that I'm standing here. If I'm standing here, I will see A and B first. And bromine will be on my left. And the carboxylic acid on my right. And then behind will be A prime and B prime. Okay. So since I'm standing here and I'm looking at this first, I have to use the horizontal groups first. So B and A, which one is higher priority? Of course, there's a bromine, so we have to use the carboxylic acid group, which is A first. And then I have to look at A prime and B prime. Which one is high in priority? Of course, this is the carboxylic acid. So I have to go towards this direction, which is to counterclockwise. So either way, you have to get the same answer. So this is S configuration. And I can draw the enantiomer of this. So the enantiomer of this will just look like and okay. So this is the enantiomer of this compound, and you can determine the RNS configuration of this easily. So assuming I'm standing here, see this A prime, B prime. Okay, in that case I'll see A and B first. And then A prime and B prime will be coming from behind. Now I'm going to see the bromine on my left, and the carboxylic acid will go to my right. Okay, so since it says looking at it from the side, I have to use the vertical side first, because carboxylic acid and hydrogen is the lowest priority. And then of this to the bromine is higher than the carboxylic acid. So I have to go from here towards this side, and that will be an R. So this is an R configuration. So always determine which side you are looking at and choose the lowest priority, and then look at the other side, which one is the highest priority, and move the arrow towards that higher priority. So in this case, of the vertical side that I'm looking at first, the hydrogen was the lowest priority, so I started from there. And then of the horizontal, which is behind the bromine, is the highest priority of the two groups, so I have to move towards the bromine. Okay, so that's how we assign RNS configuration for ATROPISOMERS. There are different structures, but still you have to use the same technique.